Hi, I'm Amanda with Technical Support.
And hi, I'm Lucas from Meltio R&D.
In this webinar, we're going to talk about the history of Meltio as a company, our technology, and the Meltio M450 value proposition and development goals. We will also cover a more in-depth view of the M450, pointing out key features, the workflow, a demo print, and applications for parts produced with the M450. We are a young company founded in 2019 as a joint venture between Aditech, a Las Vegas-based technology company, and Signova, a leading 3D printing equipment distributor. Metal 3D printing has not changed for the past 20 years. High investment, development and running costs, limited part size, part properties, and subpar user experience paired with inconvenience are all barriers for adoption of industrial metal additive manufacturing. Only a few niche applications have benefited from metal 3D printing. Some of these include small and personalized parts, components with high value and margin, as well as conceptual designs. Meltio's printing process enables the shift from niche to industrial applications. Our wire LMD technology is a directed energy deposition or DED process that uses wire material to stack weld beads on top of one another when introduced into the laser-generated melt pool. One of the most important aspects of Meltio's mission is to create the best user experience by providing easily approachable metal printing technology along with materials that have pre-verified printing profiles that operators can access through cloud download directly onto the M450 using our touchscreen interface. In the coming years, we see ourselves reaching widespread adoption of additive manufacturing technology throughout a variety of production environments.
Because of our goal for large-scale adoption of laser wire deposition, we came up with the following key criteria for the development of the Meltio M450. Safety, ease of use, space efficiency, productivity, and affordability. Now, I'm of course not going to claim that our machine is the only one in the market that meets any of these attributes, but I do think that we provide a very special balance between them that is not found elsewhere. So without further delay, let's see how we combine these attributes into our machine, starting with safety. Safety is of course the number one priority for our system design, and none of the system's features are allowed to compromise the safety of the machine. But why is this noteworthy in the first place? Of course, you can expect your printer to be safe. But in our case, safety also refers to concrete design decisions that we've made to make it convenient and easy for the operator to use the machine in a safe manner. This, for example, means that we've integrated a 3-stage filtration system in the M450 that will take out all of the fumes and particulate after printing. And this is opposed to expecting the operator to wear any kind of PPE equipment. Further, we also monitor critical components of the system throughout the builds, such as the laser fibers, for deterioration, and that means we can detect issues before they become an incident. Further, the focus on wire as a material of choice also is critical for operator safety, as this feedstock can be handled safely and does not contaminate the environment. In addition to all of those choices, of course, the focus during the construction of the system is laser and mechanical safety of the machine. Following the machine directive. This means, of course, all safety critical functions are fully interlocked and only available when it's safe to operate the machine, i.e. the door is closed, the cooling system is connected, and the operator is given the final okay. The user experience is, of course, crucial for making DED accessible. So for us, the goal on the M450 was to focus on creating a workflow that is much closer to FDM, rather than what you'd see in a typical DED process. For us, this starts with a toolpath generation using a slicer rather than a complicated CAM operation, along with very simple parameter selection and the option for Meltio supplied materials. But also other areas of the systems are really designed to improve the user experience. For instance, the focus on the wire material also really helps by making the system easy to operate, with minimum cleanup and fast turnaround times. Lastly, of course, a very big part of the user experience for any DED process is the stability of the process itself. The M450 features many sensors to monitor the printing process, and for this presentation I've picked 3 most important subsystems. Number 1, the sensor arm. This is the sensor that comes down below the deposition head to probe the height of the substrate at the beginning of each print. This way, the user doesn't need to worry about the build plate thickness or the working distance, because everything is always set up perfectly. Number 2, the load cell. This sensor measures the forces acting on the deposition head during the printing process and detects any overloading or collisions with the head. It can automatically stop the process if any errors are encountered. And number 3, process control. This is a closed-loop system that detects if there's a lack of deposition within a component, and then it adjusts the laser power and material feed rate automatically to compensate and build the part right back up to the nominal height. This system is very useful, especially when working with new materials or new parameter sets, because it means that many parts that would have failed otherwise can be recovered and finished perfectly. In case an unfixable error is detected, the system will stop automatically and alert the user. We knew from the beginning that we wanted to make a small machine that still had a decent print envelope. The key objective here was to design a system that would fit through a regular door while having the capability to produce parts that are normally only found in mid to large sized powder bed systems. The sweet spot for our machine is printing components up to about 15 kilos in weight, that is the weight of a single material spool, or up to 30 kilos with the dual wire option, but a little more about that later. The secondary focus was also to reduce the facility requirements of the system, which is achieved by using inherently safe feedstocks and integrating to discuss safety features. All of this means that the M450 can be set up in almost any environment. While the M450 is a compact system, high productivity was an explicit design requirement for its development, as the DED process only realizes its value proposition if the printing speed is high. Here we have arrived at a key technological differentiator between Meltio and other metal AM solutions by delivering a very productive system with high laser power for a low price. We achieve this very low cost of the laser by using an unconventional approach, because we don't use a single high-power laser source. We split the output across multiple lasers that are fiber-coupled into the deposition head at 200 watts each. The output is then combined at the focal spot to deliver 1.2 kilowatts. Using this method of beam combination allows us to use direct diode lasers that would normally have to be combined as pump sources in a very complex high-power laser assembly. And using them directly allows us to drive down the system cost and increase the system lifetime, because we distribute the optical energy across multiple systems, and the energy densities throughout the system are much lower. Before we go into more detail, Amanda will give an overview of the machine specifications.
Starting with general specs of the M450. The footprint of the Meltio M450 is rather small, measuring 560 by 600 millimeters and a height of 1400 millimeters, or approximately 2 by 2 feet with a height of 55 inches. Weight of the machine is 250 kilograms or 550 pounds. Single-phase or three-phase electrical circuits can be used for the main power input of the machine. The M450 includes a total laser power of 1.2 kilowatts at a wavelength of 976 nanometers. Power consumption can range from 2 to 5 kilowatts peak depending on selected options. Build volume inside the chamber is 145 by 165 millimeters on the XY axis and 400 millimeters along the Z axis, which is approximately 6 by 7 inches and a height of 16 inches. Process control enables a stable and repeatable printing experience. The M450 process control is closed loop using laser and wire modulation. There are 2 built-in wire feed cabinets, one on each side of the M450, that hold 300 millimeter spools. For cooling, the Meltio M450 comes with an active water-cooled chiller. Water from the chiller is distributed throughout the printer to effectively cool all key components in the M450. Distribution plates inside of the printer send water to the deposition head, laser source, laser power supplies, inner chamber walls, and build platform.
Going beyond the base configuration, the M450 can be equipped with 2 options: hot wire for faster printing and dual wire for multi-material printing. The hot wire module is a large current-controlled power supply that is integrated within the M450. The system works by passing a large electrical current through the deposition head and then all the way through the material to the build plate, which is grounded. The material itself forms the highest electrical resistance within the circuit and thus heats up preferentially. It works very similar to that of an old-fashioned light bulb, where the tungsten filament has the highest electrical resistance within the circuit and starts glowing white hot if the current is applied. Now, of course, the cross-section of our material is significantly thicker than that of a tungsten filament, the light bulb, and therefore our currents have to be exponentially larger as well. Critically, unlike in a welding process though, no arcs are created, meaning that the process remains clean and spark-free. The supply is modulated electrically to maintain a constant current and energy input within the system, and the hot wire energy must always be applied together with the lasers, allowing the process to be sped up. Dual wire. The dual wire option unlocks the second material feeder that is assembled in all Meltio deposition heads and allows for the production of parts within two materials. The system works by retracting material about 50 millimeters into the deposition head after use and then extending the second material shortly after through the same nozzle. This is possible because within our Meltio DLMD process, molten material is never in contact with the nozzle directly, and the material cools within a fraction of a second after being retracted from the melt pool. The dual material option allows you to apply high-value materials only in the zones of the part that really need it. For example, instead of printing the entire component from a nickel superalloy for corrosion resistance, it is far cheaper to produce the core of the part from a regular steel material and then to switch the material for the outer shell of the component where the corrosion resistance is required. The same process can also be applied for hard facing of components, where within a single process step, the complete components are built. Further, users may decide to build a sacrificial layer below their component and use that for easy and cheap machining of the material, while others just spec this option to keep the convenience of two materials loaded in the printer at all times. This option is also very interesting at the research level, especially when investigating the bonding behavior of specialty alloys or integrating functionality into parts by changing the material on the fly. The material can be changed as often as needed within the process with minimal increase in print times, and this is a feature that is truly unique to Meltio's technology. The Meltio M450 is 100% focused on wire, as that's the cleanest, safest, and most affordable metal feedstock on the market. This is furthered by the fact that we achieve excellent part resolution directly out of the machine and wire. Most of our customers are surprised by this because when they think of wire additive manufacturing, think of wire arc processes. Meltio parts, on the other hand, only require about 1.5 millimeters of overbuilding on the near net shape for machining. And thanks to the selection of the laser as our energy source, that means our thermal stresses are kept to an absolute minimum in the process. In general, our printing process using pure metal wires as feedstock achieves very good material properties with densities greater than 99.99% and part properties that typically exceed those of castings and get very close to those of forgings. Critical for the success of our mission to achieve mass adoption of this technology is our material strategy, where we allow the users to choose between Meltio supplied materials that are delivered with fully qualified printing parameters or third-party materials that can be sourced locally from a very large market of welding wires. This means it's very easy to get started with Meltio using pre-supplied materials, but you have the access to a nearly unlimited supply of specialized alloys should your applications require it. The M450 can process materials between 0.8 and 1.2 millimeters in diameter, that's approximately 0.035 inches to 0.045 inches for imperial fence. Currently, Meltio's pioneering process is compatible with most stainless steels, mild steels, tool steels, titanium alloys, and nickel alloys. And in addition to that, Invar, cobalt chrome alloys, and precious metals like gold have shown great results in customer-led projects. Meltio's current offering of materials include stainless steel 308, stainless steel 316, mild steel ER70S, titanium 64, and of course nickel 718.
Moving on to maintenance for the M450. Routine upkeep and cleaning of all parts of the Meltio M450 will keep the printer running smoothly and prevent damage to the hardware. Spending only 5 to 10 minutes after each print will prevent buildup of debris and soot, making the cleaning process a lot easier. Some of the tools needed for maintenance are provided in the M450 starter kit, and others are everyday items that can be purchased locally. On the inside of the M450, it is important to keep the gantry, components of the deposition head, printer chamber walls, as well as the door and laser-safe window, free of oxides produced during the print process.
Now for the live demo with the Meltio M450. First step of loading the material begins with the deposition head, where we have to remove a few parts for better access to the machine. I begin by removing the cover of the deposition head with a 2.5 mm Allen key. After removing the cover of the deposition head, I remove the shield gas nozzle and then the wire nozzle. The next step is to introduce the material spool into the M450. For this example, we will be using material T0, which is stored on the right-hand side of the M450 when facing the machine. Be sure not to let go of the loose end of the wire. Introduce the wire into the wire guide and push it until it comes out of the end of the deposition head. Once the material is loaded in the deposition head, we can tension the wire feeder using a 4mm hex drive. To ensure a repeatable setup, the wire tensioner is marked with a scale. For 1mm wire, we recommend a tension of 4.5. After tensioning the material, I'm going to quickly test the feeder to ensure it's fully functional. I will extrude 20mm of material and check that the feeder is working correctly. You can see the material has moved correctly, so we can move on with the next step. Next, we reassemble the wire nozzle. Thread the wire nozzle onto the wire and thread it into the deposition head. Be sure the wire nozzle is fully inserted and tensioned with a 9mm flat tube. Once the wire nozzle has been installed, please install the shield gas nozzle. As with the wire nozzle, make sure that the shield gas nozzle is screwed in all the way and tighten a little bit with the supplied tool. As the last step, reinstall the feeder cover. Once the feeder cover is reinstalled, you can cut the wire approximately 5mm from the tip. And we can close the material compartment. The next step is to load the build plate into the M450. The build plate must be sized correctly for the component that you intend to print, and please follow the guidance provided in the manual for this. To install the build plate, we will need a build plate, 4 screws, and the 10mm hex wrench. Position the build plate on the bed. Lastly, we need to load the file onto the M450. This can be done via USB stick, as we'll demonstrate here, or via Wi-Fi.
Near net shape manufacturing can be applied to a wide range of industries, including aerospace, tooling, consumer products, oil and gas, and medical. We have some parts here to demonstrate how the Meltio M450 print process is used for these different applications. The first part is a glass mold core for the manufacturing industry made out of stainless 316. This component is half of a mold used for the manufacturing of glass bottles. It has a fairly complicated geometry and is made with a material that is difficult to machine. Drivers to print this part are lead time, small batch production, and longer lasting materials. Typically made with a casting process, production times are long and require high upfront investment for tooling. The wire LMD process offers flexibility and improvements in cost. This combustion chamber is used in the aerospace industry, also made out of stainless steel. Used for a rocket engine, the part has integrated cooling channels that fuel flows through to cool down combustion chambers, mitigating the risk of overheating chamber walls. Drivers behind using the wire LMD process to produce this part are complex geometry, difficulty of machining, and additional design freedom. This is a complex geometry that's impossible to create in a traditional single-step process. The mining drill bit to be used in the oil and gas industry is made of stainless steel. This part is attached to underground drills for drilling anchor points or exploratory holes. The teeth on the drill bit wear out quickly during operations at remote sites. Lead time, cost, and machining difficulty make this part perfect for Meltio's printing process. Made out of titanium, these watch bezels are used in the jewelry industry. The component houses watch mechanics and electronics that are mass manufactured with a highly sophisticated design and surface requirements. Cost savings and reduction of scrap are driving factors to print this part. Titanium is an expensive material to machine for such a high volume product. Knee implants are used in the medical industry and are fabricated with titanium. Medical components are traditionally made from machining a billet of titanium, which is a wasteful and time-consuming process. These types of implants are sometimes 3D printed using the SLM process, but this comes with a high part cost. Cost savings, low batch production, and difficulty of machining titanium are all reasons to use the wire LMD process to create this part. The Meltio M450 enables low part cost by producing a near net shape, which can be machined in a timely manner. Meltio has different types of partners within our channel ecosystem that offer support every step of the way, offering best-in-class local service for Meltio customers. Our partners include master resellers, standard resellers, value-added resellers, along with universities and technology centers. These partners are all dedicated to fast-track the development of new materials and applications. If interested in acquiring a Meltio M450, we have an extensive sales and partner ecosystem, so it's likely that there is already one in your territory. Or you can always reach out to info@meltio3d.com to book a live demo with one of our 3D printing specialists.
Hello, everybody. Welcome back. For those of you that stayed around, we apologize for the rocky start of this podcast, but I hope towards the end of it went a bit better. If you have any questions, please type it in the comments, and yeah, we'll try and get to those. Well, how often is maintenance needed? I think, Amanda, that's a question for you.
So for maintenance, we recommend, of course, to clean the printer after each print. And this will prevent, a more in-depth cleaning. For the preventative maintenance services, we suggest every 6 months, so 2 per year.
There, of course, are like typical parts that do wear out, that label as wear parts that you want to check after every print. So, for example, the wire nozzle is the part that is always in contact with the material, and over time the material will slightly abrade that wire nozzle, and the hole will get bigger, and therefore, it's like the placement of the material within the melt gets less precise. So that's one of the parts that you want to watch out for. It's very easy to change, as you've seen in the video. It takes about 2 to 3 minutes. Other wear parts are, for example, protective lenses or protective glasses that are in the deposition head that you can take out. Very easy and cheap to replace as well. Overall, we try to make sure that the system is needs as little maintenance as possible, but the parts that do need regular maintenance, they should be easily accessible and easy and cheap to replace. We see the next question. Apologies, give us 1 second. Is it possible to send us the information about safety service from the webinar in PDF? I think what you can do is you can always get in touch with us, and then Amanda or one of our colleagues will help you out and give you the information you need.
Yeah, you can always reach out to info@meltio3d.com or support@meltio3d.com. And I believe in a week or so, maybe our marketing team is going to share the video from this webinar as well, so that can be viewed. How is operating changed in different humidities? Does it require an air-conditioned room? So for humidity, we recommend the room to be under 35% humidity. So if in a natural environment, the humidity is higher than that, it will need to be controlled within the room where the printer is.
The reason for that is that, of course, it has a water cooling system, which cools like the water for the lasers and the deposition head below ambient temperature. And this is mainly to avoid condensation inside of the printer, which can then damage electronics. What density percentage can you get with your machines? Very good question. So density of the materials, you can achieve 99.99% without any cracks. This is because you want to use like pure metal wires, so you can get basically near perfect density out of a machine. Same thing also for like tensile impact strength is also very good. Typically, materials that are printed with our technology range in between, so like what you'd expect from like a casting to all the way to forging. Typically, you'd find that our technology lies in between the two. You can reach forging level of strength with a little bit of effort. And so like very typical parts will always exceed castings. You mentioned that thermal stresses are low. Can you explain a little more as to why that is different in your system versus other additive manufacturing technologies? So key difference here is what we compare ourselves to is WAM, so wire arc additive manufacturing. That is basically a similar process, but instead of using the lasers to heat the wire, using electric arc. This is typically done in a way that's very similar to MIG welding. And there's a lot of systems in the market for that. And the reason why we like to compare ourselves to those is that they have very similar like scope of applications as we do, and albeit with lower resolution. And so like also are more attractively priced compared to the conventional, so like powder bed machines. So these would be machines that you also use to build near-net shapes. The difficulty that you have is if you use a wire arc to heat up your, or electric arc to heat up your metal, is because the arc is generated from the wire to the part, you don't really have a good control over that energy input, because if your arc length changes, your energy input changes. And basically you have to run these processes always to add a lot more energy than you could do otherwise. And even if you go to like extreme length, you go to a CMT kind of welding process, which is also kind of getting popular in the industry, you're still adding a lot more heat than you do with a laser. And that is because, number one, the arc is always very hot, and you're always reheating the layers below the part much more than you would with the laser. With the laser, you can very finely tune the energy balance as well, of what percentage of the energy actually goes into the wire, what percentage goes into substrate. And if you tune that very well, you can run a very efficient process, and that means you can print relatively quickly for a set power. And that also means that you add very little excessive energy. And if you add less excessive energy, you get lower thermal stresses. But you also sort of like you burn off fewer parts of your alloys. So that means also you get better material properties. Thank you, Abram, for the question. Alfonso asked, is the process carried out in inert gas? The answer to that is yes. Obviously, every time you heat the metal up to melting points, you need to cover it with inert gas to make sure that there's no oxidation. In the M450, you have two options for doing that. The most typical one is you just use the so like local shield gas from the nozzle. So as you might have seen in the video, there was so like a large ring nozzle at the bottom of the deposition head that's made out of copper. Out of that, we stream shielding gas that sort of like lays a shielding protective blanket over the part as you're printing it. And this is sized so that by the time that your part leaves the area of the nozzle, it will have cooled down sufficiently so it doesn't oxidize too much afterwards. And you can still get very good material properties only using this gas, even with various like demanding materials like with titanium, for example, which really like to oxidize. And we find that we get excellent strength and excellent properties and metallography out of parts that are printed without any sort of like sealed atmosphere. And what you can also do in the M450, though, is you can drive down the entire ambient atmosphere to about 1 to 2%. But of course, this is only available in the M450. If you do the same process with an engine, which is our other product line we haven't talked about today, this is likely not to be available to you. So for us, it's really key to focus that the deposition head has a really good gas shielding, because that's also what leads to good properties. Dimitris asks, what is your advice on designs that need support and get printed as topology optimized part, for example? What is the maximum deviation from the vertical axis that the FDM printer can achieve? I'm not 100% sure I follow the question, but so advice on designing support structures. Typically, I mean, obviously the M450 comes with a slicing program. The slicing program will generate support structure for you. Just to understand what support structure is, sometimes you want to print a part that has an overhang. So, you know, it has a surface that leans like this. And there's a limit to what angle you can print in the M450 because it's a 3-axis system. So we cannot tilt the head to follow the contour. We actually have to make sure that we build it like this. And if your overhang increases, that means eventually you're printing an air, which doesn't work, right? Because molten deck will just try and fall down. So to mitigate that, what you do is you build a support structure underneath that. And if you do it automatically in the slicer, that will analyze the surface and will say, cool, you cannot print that. We're going to have to put a block underneath, and that block will be built vertically. So that means if you have a part that goes like this, the slicer will say, okay, all of this, I'm just going to build a block below. So it's a big triangle. It's kind of inefficient for material use. So what you want to do is, number one, you want to try to avoid that you need support in the first place. And that means you want to follow the design guidelines of M450 to make sure that your overhang angle is within the limits of the machine can do. You can see our design guidelines, by the way, on our website. But if that's unavoidable, then the second step that you can always do is you can take your angle that you need and you can design a support structure that supports that angle, but only to the angle of the, so like support allowance as opposed to building it straight down. That will really save you a lot of material.
And the recommended overhang angle maximum is 35 degrees.
Yeah. Dimitris, I try to avoid supports, the support quality in the Meltio using the M450 stainless steel, as it's the same parts. So yeah, basically the issue that you have is when you build a support structure with our technology is you're always going to build the metal, right? It's always going to be fully soldered or welded to the part. So that means removing it will require machining, and that can be quite difficult. We find it's not that much of an issue because most likely you're going to be building so like near net shapes that require machining anyways. And most parts that we see aren't really that topology optimized to the extent that you might see part of the fusion parts to be optimized. And we like really see this technology more as something that is an enabler to print parts that would normally be made conventionally, as opposed to being so like the non-stop solution or the one-stop solution for so like really complex optimized parts for additive manufacturing. Where can I find, apologies, 1 second. Lucas asks, where can I find a map of partner CNC robot integrators and universities? Well, Amanda, I think it's on our website, but I have to admit, I don't really know the answer to that question.
Yeah, so we're happy to share, the public partners that we have. I believe they are on our website, a map of the general locations, maybe not a list of the specific names of each, but the general locations. And if you're looking for a technology center or a university in a certain area, if you reach out to us, we'll be happy to connect you with one if there's one in the area.
What she said. All right, next question. As I do research, Dimitri says, as I do research on your printer, is it possible to contact you to get some help? I'm reaching the limits of the machine. Well, of course you can.
Yes, of course. Please do. Support@meltio3d.com. I'll put it in the chat.
I believe there's already a new question, but we'll give that 1 second. But Dimitris, we will always be happy to help. You can always reach out to us or our colleagues, and we'll try and make sure that you can push the limits a little bit. Do parts produced with this technology have anisotropic mechanical properties? Do they need stress relieving treatment? Well, the answer to that is yes and no. It depends on the applications. Obviously, because the part is built up in layers, right? It's never going to be fully isotropic without a heat treatment. And we do get very close though. So we find that even for so like a little bit more demanding materials, we're typically within about 15% in terms of tensile XY versus XZ. So that would be coupons that we do tensile testing on that are extracted from a vertical build versus a horizontal build. This is quite good already. And you can always go to a full stress relief afterwards, or even then temper the part or do a heat treatment depending on the material. And that so like mostly relieves anything that is non-isotropic about the part. Gets you very consistent properties. And Dimitri says, thank you. No worries. And yeah, let us know if there's any more questions. No worries. All right, I think that might have been actually it in terms of question. Apologies. Is there any PDF where there are steps for the maintenance?
Yes, we can share that with you. We can send it via email.
And I mean, I would expect it to also be part of the product manual.
Yes, it's in the manual.
But if there's any questions, just let us know. All right, thank you, everybody. Once again, we apologize for the slightly rough start. And yeah, thank you very much for sticking around.
Dimitri, it's support@meltio3d.com.
Don't worry, we've got a Spanish laptop.
Yeah, I'm not familiar with keyboard.
But Amanda is from the United States of America, and I'm from Germany. So we're going to figure out how to put it in the chat right now. Thank you very much. Oh, but I see Lucas has already shared the help center. So I think thank you very much. So we do have very helpful people. Thank you so much. Bye.